I'm Anil Kumar, sharing with you techniques of sketching graph. The question here is, consider the function f of x equals to 5 minus square root x. Explain steps to sketch the graph of the function. Now, I'm considering this under the heading of first and second derivative analysis. But I like to give you alternate ways of sketching this graph. First method let me do with simple transformations. You really don't need calculus to sketch this function. We'll do it from the very basic things, which is a parent function, right? So we can do simple transformations here. We know that the square root x is kind of like this, right? Minus square root x means that the graph will be flipped kind of like this, and plus 5 means that it will be moved 5 units up, right? So kind of like this, where this is 5 for us. So that becomes 5 minus square root x. This is minus square root x, and that is square root x, correct? And this is 0, that is 5. So that these are very simple ways of sketching the graph using transformations. Now the point here is to also understand how to sketch using first and the second derivatives. Okay, so let's analyze the function. We know f of x is equals to 5 minus square root of x. So the derivative of this function is 0 minus. Derivative of this is 1 over 2 square root x, correct? Now clearly the critical number is at x equals to 0, right? So the critical number is x equals to 0, where it is undefined. At x equals to 0, what do we observe? At x equals to 0, we observe that it has a tangent which is very large, positive tangent, right? So that's the critical number. Now since you cannot really analyze this for increasing and decreasing, since that's the boundary also. So what we also analyze here, that square root of x works in the domain of from 0 to infinity, right? Now 0 is the starting point, so that's kind of a boundary for it. So that is the starting point. And since the derivative is negative, we know that the function is decreasing thereafter for x greater than 0, right? It is always decreasing, and that clearly indicates that at x equals to 0 we have a maximum value, right? So we have a maximum value at x equals to 0, and that is f of 0 equals to 5, correct? So we get a maximum from here. Now let's analyze the second derivative of this function. So basically we found that f prime x is equals to minus half x to the power of minus half. Then the second derivative for this function is minus half times minus half, that means plus 1 over 4, x to the power of this minus half minus 1, which is minus 3 by 2. Which you could write this as 1 over 4, 1 over, this is square root of x cubed. Is it okay? So that becomes the second derivative. Now, since we are working in the domain which is greater than 0, this is always positive, right? So we found that the second derivative is greater than 0 when x is greater than equal to, I should say, greater than 0, right? At 0 it is not defined. Since it is positive, we know that the graph should be concave up. That is to say that in this domain the graph has to have kind of a function which is always concave up, correct? And that gives you this particular shape. And bringing all this together, what we can do is we can just kind of sketch the function as we did earlier, starting at the maximum here and then concave up. We can kind of go like this. Is it okay? Of course, these values we can always always fine using the equation itself. So what you can do is you can plot some values, correct? So at x equals to 25, f of x will be 0, for example, right? So you could always write a table of values to get all other points. So that is my suggestion. So take some points to fill up the other gaps. Take some perfect squares, right? So if you use x equals to 0, then let me just make a table here. Okay. So what you can do is that you can take some values for x and calculate f of x. For example, at 0, the value will be 5. If I take x as 1, it will be 5 minus 1, which is 4. And if I take a value like 4, square root of 4 is 2, it will be 3. For 9, it will be 5 minus 3, which is 5 minus 3. Okay, so 5 minus 3 is 2. And then next best will be 16. Will be 1. 25 will give me 0. Likewise, you can continue and get some values. Is that okay? At 6 it is 36, so minus 1 at 6. Let's say this value is, at 6 we have minus 1. Minus 1. 6 and minus 1. And so on, correct? So you get a graph like this. That is how you could sketch this graph. So the idea here is that we could analyze the function using first and second derivative and then sketch. At times we can also use our simple techniques which you have learned earlier to sketch a function. I'm Anil Kumar, and I hope that helps. Thank you and all the best.